Hey Quadratics graduates, my name is Brandon Horn again. I'm here with my sexy, silky, smooth jazz over here. I'm going to be showing you some Quadratics word problems, or one actually. Okay, so a rectangle has a length that is 2 inches longer than its width. The area of the rectangle is 48 square inches. Write an expression for the area of the rectangle and solve for the dimensions of the rectangle. So, we know that area is length times the width. So area is the length times the width. Those two are together, get the idea. Okay, so we know that 48 is the area, and that's L times W. So we know that's part of our equation. So we know that it is 2 inches longer than its width. So set it up.
What is 2 inches longer than its width?
The length is 2 inches longer than the width. So we have 48 equals W plus 2. And now we actually have to account for the other W. So, because there's two widths, so we have to write another W out here, and that accounts for both of them.
I have a question.
Yeah, what's going on?
You're doing good. I just get confused with when the L disappears. So how come the L isn't in the area formula anymore? Why is it, say, W plus 2 and then W?
Because we have to scratch out that L and replace it with 2 inches longer than its width, so the L becomes W plus 2. Didn't really go anywhere, it just changed its form.
Do you have an equation I could see that so that I can see how you substituted that W plus 2 in for L?
Sure. Let's see here. So we go right here. The L is going to be replaced so length equals W plus 2. So the length equals W plus 2. So that's how we know to substitute this equation for this L. So, I mean, the L didn't really go anywhere, it just changed its form.
Okay, I see.
Yeah, it's pretty.
Thank you.
Not a problem. So we are going to work this out. Okay, 48 equals W plus 2 times W. So we're going to bring this over to both of these. Really, you could write these in parentheses, then write the W out here. Use the distributive property. So this becomes W squared, and that becomes plus 2W.
Why can't we use PEMDAS? Why do we have to distribute?
Because they're right next to each other. I mean, we have parentheses, but we have to distribute since this W is right next to that.
Since the W is right next to the L?
Exactly.
Okay.
So now we have to set this is pretty good, but we're really halfway done. We have to set this equal to 0. So this 48 is going to have to move over here, and that becomes 0 equals W to the second plus 2W minus 48.
Okay.
And then we can go on from here and work it out.
Can I use any method I want to solve from here? I could use quadratic formula or factoring?
You could, but I would kind of prefer to do factoring.
Oh, you like the factoring?
Yeah.
Okay.
So I like to do what is called the AC method. So this is A, B, and C. So we get that visible 1 right here. Okay, 1 times the negative 48 is negative 48. That goes up there. and then b equals, goes down here.
Oh, okay.
Okay.
That's fancy.
That is. So we get that negative 48 and 2, so our signs have to be different. I'm thinking 8 and 6 are going to be our terms right here. So I believe that negative is going to be right there, because 8 plus negative 6 equals 2, and 8 times negative 6 equals negative 48.
Okay.
So we're going to get rid of these, and we're going to go w to the second plus eight w minus 6w minus 48 equals 0. I just like having the 0 on the end, just a personal preference. And from here we're going to go on to factor. So we know the greatest common factor of this side of the equation right here is w. That's the only thing that can go into these two terms. And that becomes w plus 8. And we have to divide by negative 6 in order for our problem to work out here. So becomes a negative 6, and then w is 8. Okay.
Will those
So we get,
two terms always be the same in parentheses?
yes, they will.
What if they don't end up the same?
Then you know that you've done your problem wrong, because they should always be the same in the parentheses. That's a good way to check yourself, see if you're doing your problem right. Okay, so we get w minus 6 as our first one, and then w plus 8.
How'd you do that?
So we take these two outside terms right here, group them together, and these two terms right here, group them together.
And you only have to write it once.
Yeah, basically. I like to think of these like these two being like the less popular crowd. They get together, you know, provide, you know, some comfort for each other because they're lonely. They're not lonely anymore. They group up.
I get
And
it.
then these two are like really popular crowds, and they form an even bigger popular crowd by doing that.
Awesome.
That's what I like
So
to
how
do.
do we solve for a width from here?
Okay, these become just simple one-step equations because we set these apart from 0. So plus 6 w equals 6 minus 8 w equals negative 8. I personally like to just, you know, go with the opposite right here and skip over that, but you know, for people that don't really know how to get it, you know, you just set the one-step equations apart from 0.
Okay.
Just do that. Okay, so we have to solve the dimensions for the rectangle. Well, we can't really have a negative 8 as a measurement. That would just not even exist.
That's where I got stuck. I was so
Yeah.
confused. There's two answers.
So-
I don't know.
So we have to cross that out and just go with 6.
So width
So,
is 6?
yes.
What about my length here? Do I have a length?
Yeah, you have a length of, well, we got 48 right here.
So
This is
backtrack?
8, yeah.
Okay,
If you
so I have
if
to
you
go
go back
All right.
and you see that it's 8w right here, so 48, and then we equals 8 and 6. We see that 8 times 6 is 48.
Oh, so kind of a guess and check kind of process?
Yeah, basically.
Or we could probably solve it too if we wanted to. Make it 48 equals L times 6 and divide both sides. So you
48.
kind of prefer guess and check at the end when it's something kind of relatively simple math?
Yeah. I mean, you know, why go through all that extra work when you really know the answer, but you just kind of want to check.
All right, perfect. Okay.
All right. And I think
Thank
that's
you.
all we have for you today. Thank you, and have a pleasant day.